Welcome back to the Code Ryan podcast. Today I have on Akash, and I probably pronounced his name wrong, but he'll make sure to give you the correct name here in just a second. But today we're going to chat about SQL or SQL. And, when I first started kind of my developer and software engineer journey, I focused a lot on the front end, and kind of as I've gone, I've learned more and more about the back end, learned more about SQL and different like object relational mappers and things that we'll talk about today. And I think that it has definitely made me a better front end developer. So this podcast episode is going to be a little bit more focused on SQL for kind of beginners and those that might be a little bit more front end focused and that are getting into it. So if you're listening to this and you're more kind of front end, don't worry, we're going to kind of come at this from that perspective a bit. So before we kind of get into more of the kind of technical overviews of SQL and stuff like that, Akash, could you kind of give a brief background on yourself and then also give people the proper pronunciation of your name?
Thanks, Ryan. Thanks for having me on. And yeah, Akash or Aaakash is close enough. And I am the co-founder and CEO lead instructor at Jovian. We are an online education platform. We primarily have a lot of courses on data science and machine learning, but also things like SQL, data analysis, business intelligence, and a little bit of web development, front-end development as well. I have been programming since age 15, and I've had the chance to explore all the different areas of programming: front-end development, back-end development, data science, machine learning. And I like to put everything together and build things that have a bit of everything. And yeah, I'm really excited to talk about SQL, especially from the perspective of a front-end developer.
Perfect. Well, I think that with that kind of setup there, a good place for us to start is, what is SQL? I know when I kind of first started learning about this, it was like, okay, is it just like another general purpose programming language like Python or JavaScript, or is it only specific to a certain type of database, or what kind of is SQL to kind of start here?
Sure. So in most applications that you will end up building, you will have some data, some user data that you might want to save somewhere. Now, typically this user data is saved in a table or in a bunch of different tables. For example, if you have an e-commerce application, you might have one table to keep track of information about users, and one table to keep track of information about products, one table to keep track of information about orders, and so on. And you can think of tables as essentially different spreadsheets. Now, except these are much bigger than spreadsheets because you may end up having multiple millions of rows of data in each of these tables. And you need an efficient way, an efficient tool to get data out of these tables. So these tables are typically part of a database like MySQL, or there are some NoSQL databases as well, but we'll stick to the SQL databases. So databases are MySQL, Postgres, Oracle, etc. And SQL, or structured query language, is the language that is used to get data out of these tables primarily, but also insert data into these tables, delete data from tables, update the data, and maybe even create new tables and entirely new databases. So that's what it is. It has a very specific purpose to put data in and get data out of these so-called relational databases, because these tables also have relationships with each other. The products are bought by users and that is tracked within orders. So there are relationships, and SQL allows you to leverage these relationships to get not just the raw data out, but also combine data from multiple tables and do all sorts of interesting things.
Gotcha. So if I'm understanding correctly, SQL is a programming language, but it is specific to these relational databases to allow you to kind of get data from them. And then also, like you said, kind of do certain things with that data, like join data together and different things like that. So I think that provides a kind of a good setup of what it is. Now, why should someone care about what SQL is? Like if someone's maybe they're a little bit more of a front end developer, but they maybe work with some back end stuff. Is SQL like incredibly popular, or why is this a thing that someone should even care about?
Yeah, well, I personally did not care about SQL for a very long time when I was doing maybe mostly web development or maybe a little bit of backend development, but I wasn't exactly connecting to a database. But then once I started building full stack applications where I had to set up the data model, I also had to create the UI and I had to connect the UI with the data model. That is when I realized the importance of SQL. So the first reason you need to know SQL is so that you can set up your data model, so that you can decide that these are the various tables I need to have, and these are the columns I need to have in each of these tables, and each of the columns have a certain data type and certain restrictions in terms of whether they can contain a certain kind of data or not, whether they can be empty or not. So just being able to define tables is an essential skill, and that is something that you learn when you're starting out with SQL. Now, the second thing, of course, is to put data into these tables. So when you have a front-end application, let's say you've designed a login page and a user enters a password and you want to sign them up, you have to put this data into a database. So that's where you might be writing some SQL, or you might be using a wrapper on top of SQL, something like an object relational mapper, tools like Prisma, if you're familiar with those in JavaScript. Now, of course, you can get most of the functionality of SQL just by using a wrapper or some kind of a library, but sometimes you may have to do more complex things, and that is where, again, knowledge of SQL will help. So inserting data, but then retrieving data as well. So you might want to retrieve data about a user. That's again where you might use some SQL, but you might want to do more interesting things like retrieving a list of orders that a user has made within the last week using a particular payment method. Now, at that point, you are going to have to join a bunch of these tables to get that information out. And that is where your knowledge of SQL will definitely come in handy. So just being able to get the right data out of a database, just being able to manipulate data in the right ways is what SQL allows you to do. And without the knowledge of SQL, you will always have to do a bit of Googling, a bit of figuring out here and there. So it helps to just cover the basics.
Yeah, absolutely. And I know that for me, when I was primarily just starting out and focusing on front end, it was a little bit kind of scary to think about like this back end stuff, databases and SQL and all this stuff. And I think that, maybe one place that would be kind of good to go here is just maybe an overview of like, just real quick, what is a database even? And you also have kind of touched on relational versus non-relational. I think if we could just do a quick overview on what a database even is, and maybe even just some high-level differences between a non-relational and relational might help someone out if they're just kind of new to this whole idea and have been focusing mainly on kind of the front end of the stack a little bit.
Sure. Now, a database is simply a piece of software, some code running on some server, possibly on the cloud, where all of the data for your application lives. So again, sticking with the e-commerce example, all the information about the users, all the information about products, all the information about orders, all of that is sitting on some hard disk, on some server, on some cloud. And the piece of software that allows you to interact with that data, access that data, that essentially is your database server, so to speak. Now, a database can be relational, which means it can consist of tables. Now, think of tables, as I said, think of them as spreadsheets. So you have one sheet or one table for tracking information about users, and a table has rows and columns. So in the user table, for instance, you might have a user ID, you might have a username, an email, a phone number, and a bunch of information about the user. And you may have rows of data, each row representing one user. So rows and columns, that makes a table, and you put a bunch of tables together, that makes a database. Now, relational databases allow you to define relationships between tables. So you could say that a particular order contains a particular product, and the product is, and you could reference the ID of a product from a different table, a products table, and you could say that the order was placed by a particular user, and you could reference the ID of the user from the users table. So relational databases allow you to do these things called joins, where you could query for data not just from one table, but data combined across multiple tables. And you could also say things like, give me orders only from the past 7 days placed using this certain payment method, and so on. Now, non-relational databases, on the other hand, take a more flexible approach. In a lot of cases, you may not know beforehand what exactly are going to be the tables you want, or what exactly are the columns that you need in your tables or what their data type should be and so on. So in that case, you can pick a non-relational database, something like MongoDB, where what you have is instead of tables, you have something called collections. So for example, you may have a collection of users, and in each collection, you might put a document. And now coming from the front end world, you can think of a document as basically a JSON object. So each user in your database is simply going to be a JSON object, and you can pick whatever keys you want for each user, and different users can have different keys. It's not very rigid. So you just keep inserting JSON objects into the user collection. And similarly, you have a collection for products and a collection for orders. Now, the nice thing about this is that it's very flexible. You don't have to think about, okay, do I need a column when you're designing the database and so on. But the thing that relational databases give you is because the order is fixed, because the data types are fixed, they are able to allow you to query things very efficiently, get data out, combine tables more efficiently. So those are the trade-offs between relational and non-relational databases.
Perfect. I think that that's definitely helpful. And I know that databases became a lot less scary to me when I just kind of understood that this is literally just a kind of server that stores your data. Like, it's as simple as that. And I think that your breakdown of relational versus non-relational is also really good, in which, you know, it's not necessarily that one is better or worse. There's just kind of trade-offs between the two. And depending on your application, depending on your use cases, one might kind of make more sense than the other. But kind of coming back to SQL a little bit, and thank you for that kind of overview on databases there. But coming back to SQL a little bit, you mentioned kind of a few different concepts here in which you kind of talked about joins, and then you also talked about kind of having these different IDs and maybe referring a little bit to kind of like primary and foreign keys. So could we maybe cover a few of the kind of core concepts that someone's going to need to know when working with SQL? And these might not necessarily be all like SQL related. Some of them might be just like database is in general and stuff, but could we maybe cover some kind of core concepts that you think are some of the most important things that someone is or needs to know when working with SQL and maybe just working with kind of databases in general?
Absolutely. Yeah. So I think the first and the most core concept in any relational database or even non-relational database is the concept of an ID or a primary key. Now, whenever you're putting data into a table, let's say you have a table to keep track of users on your e-commerce platform, you need a one column that is going to be a unique identifier, because otherwise you may not have a way to retrieve a particular user's information again. So every table in a relational database has something called a primary key, and that's simply one of the columns. It's typically a numeric column, but it doesn't have to be. You could even use a username or an email. But the trouble there is, again, that makes things a little more complex, especially when you want to change things later on. So the common practice is just to come up with a number, and typically it's a number that gets auto-incremented. So when you insert the first row gets an ID 1, the second row gets an ID 2, the third row gets an ID 3, and so on. So there is this one column called the primary key, which is going to uniquely identify each row, which means no two rows can have the same value there. Now, how this is useful is when you want to get information about a particular user, you say select certain columns from certain table where the ID or the primary key column has the value 3. And then you're going to get the details for user number 3. So it's a quick way to retrieve information about that user. Now, another concept that is closely related is that of a foreign key. Now, suppose you have another table called orders where you're tracking information about orders placed by various users. Now, you might want to keep track of which user has placed a particular order. So let's say order number 7, you want to keep track which user placed this order. Now, instead of storing all the information about that user, what you can do is you can simply store the ID of the user. Let's say that user number 3 placed this order. And then this ID basically references the user column. And using this ID, you can now get all the information about that other user. And this is called a foreign key. So in a table, you have a column that references the primary key of another table. And it can only take values that are valid as primary keys of the other table. Now, how this is useful is when you are retrieving order information, you could say select a certain number of columns or a certain set of columns from the orders table joined with the users table on the user ID column. So in that case, with a single query, with a single command, you can not just get the order details, but you can also get the username, user email, phone number, etc. And that makes your application faster. That makes your application more efficient. And this is also used for analytics and reporting, where you might want to just create a quick report of who are all the users that have placed orders in the last 3 or 4 days. You could just write a SQL query to get all of that using joins. So primary key, foreign key, joins, I would say, are some of the core concepts people should know.
Gotcha. So I know that for me, the concepts of primary and foreign keys were definitely a little bit confusing when I started. So if I'm understating this correctly, so a foreign key is basically a way to have or to represent kind of some relationship between two different tables. So like could you even have, I don't think this is a thing, but could you even have multiple foreign keys to where like a single table is kind of having a relationship with several different tables in your database, or kind of how would something like that work?
Yeah, you can absolutely have that. So again, consider an orders table. Now, the orders table will have a primary key, which is the order ID. That is the unique identifier for each order. However, each order also corresponds to a user. So you might have a foreign key for the user. Now, apart from that, each order may also contain a certain product. So you could have a foreign key relating to that product. Now, I'm using a very simple mental model here where one order only has one product, but typically orders might have multiple products, and there we may want to create a third table so that we could keep track of multiple products within an order, but let's not go there. So one table, so the orders table would have a primary key order ID, a foreign key to the users table, a foreign key to the product table, and you can join all three together. You could do a three-way join and you could get all that data together at once.
And am I correct in that you can have like these multiple relationships between tables, but when it comes to that primary key, you are only going to have one single primary key representing kind of one, like you said, one order within the orders table. Is that correct?
That's correct. However, you can have a primary key consisting of two columns. So you can have an order ID, but you could also say that, okay, I have two columns, both of them together represent my primary key, in which case the combinations have to be unique. It's a very rare case. Relational databases allow you to do that. But the most common case is you say one column, one primary key, and it's unique.
Awesome. I think that provides a good understanding of a few of the core concepts there. And kind of moving from that a little bit. So with these ideas of joins and different things like that, there's also this concept of data indexing, which someone kind of might hear from time to time. Maybe a good place for us to go would be what kind of is data indexing, if someone hears that, and what's kind of the purpose of doing something like that?
Yeah. So when you set up a table with a certain primary key, behind the scenes, your database server performs something called indexing, which allows you to query that data easily. So it essentially sets up some kind of a tree, so that let's say you're searching for a particular primary key, instead of having to look through the entire table, it can efficiently just look through a few of the rows, and it can identify that particular row of data and retrieve that for you, right? So instead of scanning the entire table, it just gets that very quickly in logarithmic time, to be more precise. Now, the trouble here is you're not always going to query by your primary key. You're not always going to say, give me user with ID 10. Sometimes you want to get the user with a particular name, first name, or with a particular email, or with a particular phone number. Now, your database doesn't know that you want to query by all of these other columns as well. So in that case, your database will have to just scan the entire table from the top, looking for the user with the first name Ryan. Now, what you can do while you're defining your table is you can mention that you want to index the table not just on the primary key, but also on this column called first name, or also on this column called email. So then your database will, apart from storing the data, your database will also set up this efficient representation for searching through the table using the first name column. And then when I say, give me the user with the first name Ryan, it's going to give me that in a much more efficient fashion. And we're talking probably thousands of times faster. So it's important to make sure that whenever you're going to query or filter based on a particular column, you have set up an index on that column.
Gotcha. And is it also important to only kind of do that optimization when you need it? Because someone listening to this might hear that and say, well, why wouldn't you just like index everything and have everything indexed so it's always just super fast? I'm guessing there's also a cost to doing that, and maybe that premature optimization there might actually slow down performance of your database, or why wouldn't someone just kind of index everything if it's faster?
Yeah, so that's a good question. And generally speaking, you will probably be fine if you index all or most of your columns, not all. Where you might run into trouble is each index ultimately has to be stored on the database server itself. So it may occupy some disk space. So that gives you less space to store the actual data that you want to store in your tables. Some of the columns which might be, let's say, text columns, which might have a lot of data, the indexing process itself might become very slow. And what has to happen is every time a new row of data is added into a particular table, all of these indexes have to be regenerated or at least updated in some fashion. Now, the more indexes you have, the longer it is going to take to update these indexes. So the slower your database is going to get for write operations, right? So indexes make your reads faster, but they may potentially slow down your writes if you have too many indexes, especially on especially on columns that can contain a lot of data. So I would say start by asking yourself while creating the table, what are the fields that I might want to query by, right? What are the fields that I might want to filter by? What are the fields that I might want to order by? Then let me go ahead and index those. But at the same time, there are going to be a bunch of fields that you're not necessarily going to query search by. Essentially, for example, a bio field. A bio might be really long, but you might almost never sort the results by bio or even search for something within a bio. So in that case, it doesn't make sense to index it. And the index also itself is going to be really large.
Perfect. I think that provides a really good understanding of data indexing and selfishly helps me out as well. So that's really helpful. And maybe kind of bringing it back to SQL a little bit here. So with SQL being kind of its own language, is it similar to something like Python and JavaScript in which it allows looping and conditionals and different features like that, maybe even functions? Or is it maybe a little bit more raw and doesn't kind of allow some of those things? Or how's it kind of work when it comes to some different things like that?
Yeah, well, the answer is no and yes. No, because the most common form in which you're going to use SQL is not going to look like Python or JavaScript, in the sense that you will not be defining functions and using variables and using loops, etc. All those things are there, but the most common form of SQL is actually something very close to English. You say something along the lines of select column 1, column 2, column 3 from table, join table on certain column where a certain column has a certain value, order by a certain thing, group by a certain thing, and sort by or limit to a certain the top 100 rows or something. So it is far more declarative in that fashion, in the sense you just describe what you want from the table and what conditions that data should satisfy. And SQL does all that hunting from the table for you. So you don't have to write a for loop to go over each row in the table and search things. So you might find it actually quite similar to something like the pandas library in Python, where again, it has like a data frame, which is essentially a table internally, and you can just say what you want in terms of data that satisfies certain criteria, and it's just going to give you those rows of data. So the most common form of SQL, you're not going to be writing functions, loops, etc. You're just going to follow this template syntax, and in a lot of cases, you can just type in what you want in English into a tool like ChatGPT and get a pretty good starting point for a SQL query. However, SQL does have some of these advanced constructs. It has a way for you to do if-else using something called a case clause. It has a way for you to do loops or recursion. It has a way for you to define functions. All of that is there, but that's more advanced usage that is probably not necessary. And especially as a front-end developer, you might almost never have to use.
Awesome. And I think kind of Similarly related to this, you're not always going to be writing just the raw SQL. You might be using something like an object relational mapper, as I know that in our program for my job, we use Django and use kind of the Django ORM. So if someone, and when I first heard of an ORM, I was like, I don't know what that is. I write JavaScript. Well, what are you talking about? So, what is this, and how does something like this kind of work?
Yeah, so ORM stands for Object Relational Mapper or Object Relational Mapping. The idea here is most developers, whether they're front-end or back-end developers, probably don't want to write their own SQL because they might make mistakes. They might allow people to exploit their queries. There's something called SQL injection. So they might allow people to exploit vulnerabilities in the queries they write. So because it's so easy to get SQL wrong, and especially for programmers who do not have a very deep understanding or knowledge or experience with SQL, most languages have tools or libraries that can wrap your databases essentially, and by giving you classes. So you talked about Django. Django has an ORM where you can basically define every table as a class. So you can say that you have a class user and you have to extend a default class like model or something. And then you just have one property for each column. And then you also indicate its type. And what happens is now when you run your application, you have all these classes that have been defined for each table that you have in your database, and you provide just a connection string, which is the location of your database, the password, the username, etc. And Django connects to your database, issues SQL queries, and extracts information from the table and gives you these objects of those classes that you've defined. So you never have to think beyond Python. In your code, you can just say, give me the users where ID equal to such and such, and it's going to construct a SQL query, get the data from the database, convert that back into objects, and then you can use it in Python as you normally would. Similarly, in JavaScript, you have a tool called Prisma. It works the exact same way. You just write a bunch of files defining what your database tables look like. And in your Node.js code, you simply use the Prisma library and you issue a query that converts to SQL, gets data out, gives you a bunch of nicely formatted JSON objects, and you can work with that. So just makes life easier for you.
Perfect. And as you said, these are just kind of wrappers around your SQL. I've found that it is still kind of helpful to understand what's going on with SQL. And like even within the Django ORM, there's been times to where it just makes sense to write some custom SQL and to kind of use that within that. And I'm guessing a lot of ORMs would allow you to do that sometimes if you need to kind of do a bit more kind of customizations there. So I would say these tools, object relational mappers, have definitely been helpful for me being a database and SQL guy, but still kind of having a rough overview of what it's kind of actually doing is definitely helpful, as kind of, I would say, is applicable to a lot of things, whether you're using a framework like React, kind of understanding how JavaScript works under the hood and stuff like that is helpful as well. So I think with that, Akash, we're coming up on time here. Is there any kind of final takeaways regarding SQL that you want to leave someone with, or anything that they should kind of look out for when using SQL or anything like that?
Sure. Yeah. Well, when I got started using SQL, I was not the biggest fan, coming from languages like Python and JavaScript, where one, you have a fairly limited number of concepts in terms of loops, variables, if-else conditions, etc. But second, you also have a lot of control over what you can do. So SQL felt a bit restrictive at first, and also the syntax felt a bit weird and funny at first. But then over time, I realized that it is built for a specific purpose, which is to inform your database server what you want and let it figure out the most efficient way to give you that information. And there's a lot of optimization that is performed under the hood to make sure the SQL queries that you write can run efficiently on databases containing millions or even billions of rows of data and give you back exactly what you need in a very short time. So I would say embrace SQL for what it is. Don't be afraid of it. It's just different. It's not necessarily difficult or weird. It's just different. Give it some time. And more important than the syntax is to understand the concepts. Understand the concept of a table, understand the concept of a primary key, understand the concept of a foreign key, understand the concept of a join, understand the concept of a grouping and aggregation. The idea is, even if you're using an ORM, you may not have to write SQL, but you'll still have to know what a join is and how to do a join and which kind of join you need or how to aggregate things. So make sure you understand these concepts, and I would say just take a basic SQL course over a weekend, and that should set you up for several years of programming with SQL. It's not really that big of a language. It just has a few concepts that you have to learn.
Absolutely. And if someone wants to kind of find one of these courses, I believe you have a good place to direct them, or if they want to find some more of your content online and want to keep up with what you're doing or to find the courses you've done on SQL, where can kind of people go to find that stuff?
Well, so we have a beginner friendly course on SQL on our YouTube channel. So you can head over to youtube.com/@JovinHQ. So @JovinHQ is our handle. We've also partnered with Free Code Camp to put up the same content on their channel as well. So if you just search for SQL Jovian, you should find our course. And we have a bunch of other courses related to Python programming, data science, machine learning, web development as well. For that, you can head over to jovian.com. That's where we host most of our courses.
Awesome. Well, thank you so much for coming on today. I will definitely testify that I found your course through Free Code Camp, and I went through it. And as a front-end developer, it was still very approachable. And as you mentioned, you still covered the concepts. Some of those courses just they kind of dive into the syntax and don't really explain the concepts behind why they're doing stuff. And I think you did a great job of that. So with that, thank you so much for coming on today. And I really enjoyed the conversation.
Well, thanks for having me on, Ryan. And this was a pleasure. I really enjoyed the conversation as well.